Hello, good evening, good afternoon, and good morning. I think it depends on which part of the globe you live. Yes, I think there is some echo. I have to fix. Okay. So my name is Tomasz Jaskula, and I'll be running the tonight's shot. I'm part of the DDD and Office of Strategic Software communities. So I'm very proud and to bring to you on behalf of Domain-Driven Design France and Office of Strategic Software a very interesting discussion about microservices. I'm not sure if the term is still hyped as it was a few years ago, but I think there is still confusion around it, and today I hope you'll get a clear idea of what has to be what you have to keep in mind for microservices when you start to bring this kind of architectural style to your company. So of course we are streaming today on DDDFR YouTube channel and OSS Strategic Office of Strategic Software channel, which is Twitch channel. You can interact with us with comments. So yeah, there are a few comments. You will show popping them on the screen. And we'll try to pick the best comments or questions. If you have any specific questions to speakers, just ask them. I'll be watching the event stream and we'll try to bring them to speakers. So as we are going to start, I'm not going to compose any music today, nor software. Let's go around the table and introduce people that we have on a call. So we have...
Hello. Hello, I'm Jérémie Chassaing. I live in Paris and work in Paris too, in a company called DH, which is working for hospitality. And we started using microservices in 2008, 2009. So we have a bit more than 10 years of experience with that. So this is what I'm here for talking about.
Thank you. Who we have? Susanne.
Hello, everyone. I am Susanne Kaiser. I am an independent tech consultant from Hamburg, Germany. And I help organizations with building and running services from software design to software architecture and to run them in production. And I was previously startup CTO here in Hamburg, transforming our monolith architecture from monoliths to microservices.
Thank you. Who we have? Jimmy.
Hey everyone, my name is Jimmy Bogard, independent tech consultant here as well, out of Austin, Texas, where everything is still heavily locked down. And I can probably say I was doing microservices before they were cool, I guess.
Great. And Vaughn.
Hi, I'm Vernon. I'm over here in Arizona, USA, near the Scottsdale, Phoenix area. You probably know me best for some books that I've written about DDD, although more recently I've been focused a lot on developing the DDD-friendly reactive platform called VLINGO. You can find out about it at VLINGO.io. Actually, I know zero about microservices or monoliths, and that's why Adam and I are going to first set a truck ablaze and then drive it full speed into both monoliths and microservices and find out if they are myths or busted.
Great. Next one, Vladik.
Hey, my name is Vladik Khononov. I am from Israel. Currently, I'm a senior cloud architect for a company called DoiT International. Before that, I've been practicing domain-driven design for over 10 years, and I've been failing at doing microservices for about 5 years. Currently, my main interest is more in the underlying software design principles that are shared across domain-driven design, microservices, and design patterns.
Oh, great. So today we're gonna discuss a few big topics. I don't think that given the allotted time we'll have to talk about everything, but if you have any questions, just ask on comment on YouTube and Twitch, and we'll try to answer them the best we can possibly. So let's go with the first topic that we have, and introduction to microservices. So what does this mean? Maybe we should define what the microservices are and how they are different from other types of architecture. Is this architecture or architectural style? So who wants to start? Jérémie, you.
I'm on screen.
You were laughing, so it's your turn.
Yes. I'm still not totally sure about what people think when they talk about microservices, but still there has been a shift in the last 10 years about the way we build large systems. It seems so, and this is part of it, the splitting of the application in many small independent parts that work together to deliver the service, and leveraging more infrastructure than actually going through more code inside the same process or thing like that. This is mostly going in this direction for me.
Okay. And yeah, I recently saw that some of the people think just splitting soft of the random feature, or maybe not random, but not careful thought features into different deployable units and making them work through, for example, HTTP. Does them make microservices, or I don't know how we can answer this question.
In a way, it would be microservices, but with you getting in trouble. So don't do it this way. There are some architectural concerns, organizational concerns, infrastructural concerns, modeling concerns to take into account to make it happen in a good condition. So there are probably a lot of things to learn from people who tried it here along the way. But yes, just creating the services, just doing microservices is creating microservices. But yeah, of course, you'll get in trouble. Like if you create a bunch of lines of code and without structuring them, you'll get in trouble too. So yes, there are a lot of principles to learn to actually be able to manage it at scale.
Yeah. And does anyone else has a different opinion, or maybe different definition?
Isn't microservices where we use Kubernetes and containers to deploy applications? That's
yeah, I think this is
the baseline.
Yeah, this is very hyped today to put Kubernetes everywhere. So yeah, that should be the.
I never liked the definition in the book personally, because it was like something that's small and does one thing well. Like that's all. Those are all completely subjective criteria. So what I like to think about myself personally is microservices being a service-oriented style architecture in which our design goal is to have smaller service boundaries. So you start with SOA, and your direction is small service boundaries, as opposed to just picking a boundary and saying, that's good enough.
Yeah, and what's defines good boundaries? In fact,
well, if I might chime in. That's why I've decided to talk about domain-driven design bounded context as a way to set a service boundary, at least to begin with. It doesn't mean that putting some number of entity types inside a boundary is the perfect size of microservice, but I would say for probably a very, very high percentage, in the 90% range, that's probably a really good size for microservices, given that most people don't have to worry about the incredible scalability throughput that microservices are used in some cases, like in the FANG world.
So I would also put my 2 cents into that one. So define the right boundaries is mostly to benefit from microservices. It's essential that you follow some key principles, and the key principles of to create good candidates for microservices and to benefit from microservices. And the key principles are high cohesion within a service and loose coupling between those services. And usually high cohesion within one service is usually reflected by related behavior that shall stay together, for example, bounded context and domain-driven design. And regarding the size, I would say, because I guess the term micro and microservice is very conflicting. It's not the size that is important, because it's really hard to measure. Like, lines of code in different programming languages means something totally different. So I rather would like to tackle the size of a microservice from the team perspective and its cognitive load. Like, for example, how many services can a team handle, and match the service boundary size itself more to the team cognitive load itself, not from the technical perspective, but more from the team perspective.
Yeah, I'd like to add something here. I do agree with both Jimmy and Susanne about minimizing those boundaries and cognitive load, high cohesion, low coupling. And what I wanted to add is, when we were speaking about microservices, every time someone refers to a service as a microservice, for example, in Kubernetes tutorials, they love to do it, I die inside a bit. Because in my opinion, microservices exist only in the boundaries of the system that those services are components of. And that's probably the hill I'm going to die on. I love this analogy from way back from the procedural programming days. It's part of structured design, and they used this way of assessing the complexity of a system. They had this local complexity of a service and global complexity of the interactions between the components of that system. And the goal always was to balance those complexities, to make sure that the system as a whole is not complex, but also to make sure that those services are understandable by the team who has to implement them. So, of course, we can optimize. I have no idea why my table is beeping here. I'm sorry for that.
No problem.
Anyway, if we optimize only for system-wide complexity, well, we can create just a big monolith. And of course, its local complexity is going to be high. If we optimize only the complexity of the services, then we'll get those 10 lines of code microservices that everybody has been speaking about at the beginning of this trend. And of course, that would result in an unmaintainable system. So for me, we have to find a balance between the complexity of a service and a complexity of the whole system. And for that, we have to take into account the whole system, not one specific service.
Okay, I think this brings us to the next topic, which will be about the organization and teams. Let's see. Because I think there has to be some alignment with what is really delivered and how the company trying to implement microservices is organized, don't you think?
So microservices are often referenced in context of the organizations and teams implementing them. And we had this analogy of a microservice is a service that can be implemented by a team that we can feed with 2 pizzas. Now, in my previous company, we were 2.5 people. I'm the half. We could be fed with 1 pizza. And I dare somebody to call that system a microservice. Mm-hmm. That was an insane monolith. So yeah, when you have a lot of teams, yeah, that makes it very convenient to organize the work and split it depending on those microservices. But still, I think that, as Vaughn mentioned earlier, we have those domain-driven designs, bounded contexts. And if you have conflicting models, even if you're just one team, you still have to decompose the system using those linguistic boundaries of those models. So for me, microservices and people-related stuff, they have some connection, but microservices are not, for me, at least in my opinion, are not driven only by organization of work into different teams.
It has probably more to do with the capacity of autonomy and deployment. So sometimes it makes a fit with the organization, and often it has to be quite aligned with the organization. It's more complicated when you always have to synchronize a lot of people to make any release, to not crash the system. So when you have a lot of small independent parts that can be really autonomous, that can be delivered independently, it can ease the deployment and the progress of the application, since it requires a lot less of synchronization, and it makes deployment usually less scary. But given that, the problem also is that when you have a lot of small independent parts to deploy, it becomes also something quite complex to follow the interdependency and all that. And sometimes if you have to deploy one thing independently, but actually it makes no sense in the context of the business of that part, or in the global meaning of that part, to deploy it independently. Maybe if you have a lot of things that used to change together, even if you can deploy them independently, it's more infrastructure cost to actually organize all those small deployments compared to a larger one. So I would more. I think there are mostly three aspects here. There is the deployment unit, there is the teams, and there is also the force that act on the system to change it. So your system is not changing for no reason. There are some external actors, the customers, the business, and all that want to modify the systems over time. And due to that, you will have to change it and make some new deployments with new code. And sometimes all the force is coming from a single direction. For instance, the business is giving the way change after analyzing the business requirements and all that. And then you can just organize your deployments as units that you can do on a regular basis, and you're in charge of that. And at that point, it's quite easy to have one deployment per product. But as some part of your product are not dependent of your own will, for instance, you have external partners that can change their API without any further notice, and things like that. You're not in charge of all the forces that act on your systems, and being able to deploy each part independently becomes very, very valuable, because if a part of the system is under change for the next 2 weeks or for the next month, and another part of your system just changed today and you will have to release now, having them separated lowers the risks. So analyzing the force that produce change on your system and your way to actually manage them will be also a good guide to know where to split the boundaries.
Okay, I have one question from YouTube. How to persuade management and decision makers that microservices are not magic wand that you will save a monolith app?
This is for me.
It's for anyone who wants to take a stab.
Okay.
So let's go, Vaughn.
Oh, well, I think in all of this discussion, maybe one thing that needs to be considered is Conway's Law. If you go clear back to 1967, 68, when Mel Conway released this paper about how systems are built and how communication affects the way systems are built, it plays in really big to all of this, and the whole factor is your communication structures will have this ultimate impact on the way that you design a system. And the way that's interpreted a lot is, okay, if we have 3 teams, then there will be 3 subsystems. And then there's this modern expression or name that says we're going to use the reverse Conway maneuver, which means we're going to set up the organization so that we can succeed in the way that we want to succeed. So in other words, we create our own communication structures. I just want to point out that even though that is probably a good way to try to operate, I don't know why they call it reverse Conway maneuver, because Mel Conway actually addressed that at the end of his paper. So I think that one sentence or two always gets quoted, but should really read the rest of that paper, which at the end says basically set up your teams to succeed. and so that it's part of the way to succeed within Conway's Law. So the point being that where are the natural communication structures occurring? And within the business, you have to look at who do we have conversations with when we're talking about these things. Because if we start setting up, structures based on, merely some almost arbitrary, concept of how are we going to deploy this, or what department are we in, or something like that, it tends to create these kind of artificial boundaries that aren't really about the natural conversation structures that should occur. And so what I'm going to suggest is first study the conversation patterns that you have and with what people are involved, and then attempt to feed the appropriate people into those conversations, and those who can handle, let's say, for example, Susanne's point about cognitive load, who can handle the cognitive load around those conversations, which probably means, your brightest, most mature software developers, and who are okay with interacting with the business, as in, Vladik there has this great t-shirt, introvert, and that's cool, but I'm an introvert too, but we got to turn on the communication channel when we get into these situations, or we're going to be, just another cog in the wheel. So I'm going to suggest that we talk to management about what is the best way to actually build software. It's about the conversations. So let's set up structures around the conversations and who has the expertise and who can comprehend and succeed in those areas with those experts. And it may even mean having a more fluid organization than these, strict hierarchies that have been more familiar to us in the past.
Yeah, and what if the organization is really, hard to move, and how can we, reach to what kind of people to change the organization, because obviously it has to be aligned with what we are going to do with microservices, but moving teams around, it's not an easy operation, and especially if you are on the level of software engineering, it's always quite difficult to say how to do it. Are there any tools except for conversation that can help to talk with business people or with people that decide? How can we show them where we are going to do, and what are they going to benefit from if we go to microservices?
I guess what is very important when talking to management is how, I have to move to that side, what kind of goal we try to achieve when introducing microservices, because microservices itself as a goal is not the goal itself, it's the path to our goal, right? So what we try to achieve when introducing microservices, and one goal could be, for example, reduce the time to market for new features that we would like to implement, to add to our product itself, and to increase the software delivery performance, because the software delivery performance, according to 4 years research run by Nicole Forster and Jess Humble and Jean Kim in their book Accelerate, have proved that the software delivery performance has a huge impact on the market share, the profitability and productivity of your organization. So, and to link these goals in terms of to reduce the time to market, and for that one, we would like to introduce microservices, but it also comes with cost, but it's an investment in our future, software architecture, and it requires also that we have to adjust our, as Vaughn mentioned, that we have to build our organization around the conversation that we have. And we can also start with small services and small teams first. So before we reorganize the entire company, we could start, for example, with small services first, and to see to build services in a small context first, and then go on and move on further on.
Mm-hmm. And I know how we can be sure what is the value chain in an organization, because obviously I think this is something we have to discover, and it's not always very easy to see at the first sight. I know something like worldies maps can help with that, or to.
Yeah. So yeah, worldly maps are a very great tool to visualize your business landscape and the evolution of your value chain. So Worldly Map has been created by Simon Wardley, a researcher from the UK, and it consists only of an x-axis and a y-axis and an x-axis, and on the y-axis you are plotting your value chain. So behind every user need that you have, there is a value chain consisting of your users, their user needs, and all these components and activities that fulfill these user needs. Mm-hmm. And on the x-axis we have different evolution stages going from genesis to custom build to product and rental and to commodity evolution stage. And so the Worldly Map itself helps to, it's kind of like strategic tool in terms of like what kind of system we would like to build and focus on the user needs. And the user needs in themselves, they are the purpose of our business itself, what we would like to provide to our users themselves, and what kind of components and activities are necessary to fulfill these user needs. And for example, it could be like then split into a user need could be, for example, fulfilled by microservices, one microservice fulfilling specific functionality of our business domain, and this business domain and this microservice is then needing data components and so on, and this running on a specific infrastructure. And what you would like to highlight is that you strategically invest in those components and activities most that give you competitive advantage, and that's why you have to strategically invest most. And for example, that's why you say, okay, I have to build this as microservices, for example, and to build this on one in-house, and other components I can outsource to commodity suppliers, for example, that you run your infrastructure on serverless, or that you are integrating cloud-hosted solutions for authentication, authorization, and so on. So the Worldly Map itself helped me a lot, for example, talking to the management of my clients to visualize what the current status we are currently now in, and how our system can evolve over time, going from evolution stage to evolution stage.
Okay, so definitely this is the tool that I think it's quite recent, maybe 2 or 3 years now, if I'm not wrong, the Worldly Maps. So I don't know if it's widely spread in the organization. Anyone else has already used
so
it?
Another tool I like to use is value stream mapping. This came from the manufacturing industry, but it really works for any kind of value stream. And what I like to use that for is when I'm talking to the business about their goals, about why they want to move from this monolith system to something else, whatever that might be, then we have to understand, well, what are their current pain points and bottlenecks? And value stream mapping is a great tool to help visualize, like, for any kind of valuable process that they have, where they're spending the time and how a different tool or process might improve that overall flow. And that can help, especially when we're talking about securing budget for these kinds of efforts. Along with the Worldly Maps, it also can kind of show like where like if you spend a little money here, you can get a big return on your investment over there. So having that kind of two different angles can really help with the people that actually sign the checks, where they should actually spend their time and money. But if someone says like microservices are going to solve all their problems, those are probably the same kind of folks that think like SAP or Oracle are going to solve other problems. And I don't golf a lot, so I don't get to be in the place where those decisions are made. It's going to handshake deals where they buy some giant tool to solve all their problems. So it can be really hard to walk someone down from an assumption that a different architectural style is just going to magically make all the current problems go away.
I just want to make a prediction. I love the idea there, Jimmy, but I predict that wordly maps are going to become much better known in the near future. That's my prediction.
So let's wait 1 year and check if the prediction comes true. But
for sure,
it's very probably it will. Yeah, so I think let's go to the next topic because team organization. I think the most important part we've already discussed. But what's the next is that we have microservices. But what about monoliths? Are the monoliths good to put to the trash, or they are still valuable architectures? What do you think about? Who wants to start?
Well, I'm not writing a book on it.
No one wants to talk about monoliths. It's like I don't want to publicly say that it's good or not. No? Jimmy, go ahead.
I hate the term, for one. Like, it's not like a binary choice anyone makes. Like, you know what? Today I'm gonna build a monolith because that's what that's my two choices. I can't say the companies that I know that I've worked with that are moving from a very large system trying to go to smaller systems. The reasons why they're doing that are, one, either the technology itself is not modern enough to help them deliver the value that they need to in the future. So although it was successful in the past, it can't continue forward. And a great example is like, companies that did mainframe for everything. You can't expose a mainframe to the modern web easily. So they have to have something else to be able to bridge that gap. Or the cases where the system got too large, where it encompassed, in DDD terms, too many bounded contexts, and you have all these multiple competing priorities where you can no longer move forward because the time to introduce a new feature is dwarfed by the time to make sure you didn't break anything. And so the only way you can really move forward is to say, okay, we need to break things into smaller pieces. So I never see it's like necessarily a choice people make. But for me, the term monolith really encompasses an application that has outgrown its boundaries of usefulness for the organization. And the only way to really move forward is to have smaller boundaries that are much more cohesive and less coupled.
And I would probably not recommend to start microservices before you know that your product will actually be used and that you will have to move on scale and divide on having multiple products and all that, because the operational cost of running microservices is not low, and putting all the infrastructure in place to see what's happening in such system takes some time that you could at first invest far more in actually building the product and putting the value where the value has to be. And but you have to get ready for this move if you succeed, and then you have a growing product, and at some point having only a one monolith will get you into trouble. So knowing how microservices work and being ready for moving, at first probably having some themes for things like bounded contexts or being ready to split between teams and all that being prepared is important, but starting directly with all these small services and all that is probably losing some time for your business. So.
Yeah, I agree with that. And specifically, like saying when you're still unclear with your domain and you don't know whether your product will, or your services that you provide to your customers, to your users, will hit the nerve or the request from your users themselves. And also one scenario, because I was running into that one, is if, for example, so one of the definition of microservices is that you or one of the capacities that you have with microservices that you can deploy them independently. And but if you are running into the scenario where, for example, you're providing a product for your customers that are going to be installed and managed by your customers themselves, then I guess microservices will be counterproductive, because then you don't really gain benefit from introducing microservices, because at the end you are providing one artifact to your customers, which they will deploy on their system, on their infrastructure. But if you are then in the transition from where you solely run on-premise, customer installed on-premise software, then going to the transition to run cloud native, and you have all these requirements in place, like that you're embracing DevOps culture and have automated your infrastructure and so on, which is really important, and have a robust monitoring, then definitely microservices make more sense. But it depends on the context itself. It's not that I would say monoliths or legacy systems are bad. That's not the case at all. It depends on the context whether you are in a position to introduce microservices or not.
Yeah, and I think since some time I'm seeing some tweets around that people are going back to monoliths. So one of the tweets I can just bring to you, let's say, so something like this one. We have moving to a monolith allowed us to read our pipeline of operational issues while significantly increasing developers' productivity. So there should be some issues when you go too early to monolith, to microservices. So definitely there are some. Yeah.
If I may offer, monolith is actually not a bad word. You know, the word monolith has been kind of thrown, or the idea of monolith has been thrown under the bus, but it's really big ball of mud that's the problem, right? So just to distinguish, you can have a very well modularized monolith that can make it very straightforward to extract smaller services out of that and deploy them separately, or you can have a big ball of mud like most large organizations do, and even probably everybody, and it can become a gigantic effort to try to extract even a few microservices out of that. And you may never be able to fully shut down the monolith because of just the complexity of trying to get there without interrupting your revenue stream. So there is a big difference, and I think we should emphasize that more, that monolith is not actually a bad idea.
Yeah, I have one question from the audience. So Amin is asking, modular monolith with well-done boundaries, isn't that less risky to maintain and scale than?
It depends, because if the small parts, for instance, are supporting very different part of your system with different risk outcome, having them deployed together with the same runtime running them, you're in the risk of failing all your system because the small part that is less important and cut a more important part of your business. So from a risk strategy, moving them apart can be interesting. And for instance, also if you have a large part of your system that is passing through some code on a smaller part that is passing for another part of code, splitting them enables you to actually scale only the parts that need scaling and having simpler infrastructure for other parts. So from a risk management, yes, it's less complicated, but you can also endanger some critical parts due to the rest of the code. So yeah, this is where you have to be careful with risks.
I agree with that. Another thing to consider is, if the rate of change of one of your modules or multiple modules in your monolith becomes greater than several others, and the others are kind of holding back deployment for the ones that need to release more often, then that's a good idea to extract those boundaries outside, and move them into their own microservice. But the point is that you can actually accomplish that with relative, at least acceptable complexity rather than unknown complexities. And the other thing I would offer, though, about the risk of operational integrity is that there are, patterns like bulkheading and so forth that can protect against bringing down the entire, deployment of or node or whatever it is because of a single service failure. Obviously, again, that is not just super simple, but a good place to start with that is using reactive-based supervision, which means that the supervision of failure is offloaded to a dedicated, resource, a dedicated component, rather than being left to chance that someone above you can handle the exception or whatever, connection, disconnection, or whatever it happens to be.
Okay.
I'd like to add something here. In my opinion, my experience, it's less risky to start with the modular monolith, make sure that it's modular, and make sure that it's not a big ball of mud. And once you have that code base that is manageable, then you can make those decisions that Vaughn and Jérémie spoke about. If you identify some areas that are more risky or you have other business concerns, well, you definitely can extract them to a microservice or whatever. But if, on the other hand, you start a new greenfield project, you're not familiar with the business domain, and you decompose it prematurely into those microservices, making some assumptions about the business, and later find out that those assumptions were wrong, well, you're in a bad place, because a distributed big ball of mud it's a suicide. I never saw a distributed big ball of mud being refactored into a manageable code base. Those were my 5 cents.
Yeah, and you were talking a bit about coupling before, and one question from the audience was, is it okay if we have like one microservices which is having a lot of calls from different microservices? I mean, there is different maybe kind of coupling to look at, and not only the technical couplings, but as well maybe business processes can be the part of the coupling, that some of the services are not well designed. What's your experience?
Yeah, so first of all, it depends. It depends why there are so many calls. It depends on the rate of changes. what happens if this central service has to change? Does it mean that all the rest of them have to change as well, or can it be managed and evolved independently? And what are the other options like? Why are those other services so dependent on this one? Maybe the business logic is just spread between those number of services. Well, that's probably a bad design decision. But if, on the other hand, I don't know, one of them just provides an atomic clock, then why not? So
Yes, so I can. I'm sorry.
Yeah, so what I want to say, sorry, but it depends. We love to give this answer. We hate to receive it, but it depends.
One service or kind of service that can be called a lot of times is services with cross-cutting concerns. For example, how to handle authorization, authentication, or something like that. For example, it could be that. So these are if we have a service that are called by other services very frequently, we have to make sure that this service is pretty stable. That is not changing its behavior a lot of times, so that other services that calling these services, this centralized service, that's how I would call it, have to be adjusted every time a behavior change. So if it's a very stable one in terms of like stable behavior, then I would not see so much concern into that one, with the requirement that it's scalable in terms of that it can and then address also the high load that it's get requested to.
Yeah, I think it brings us to the question we've been already discussing a bit, but more about modeling, and this is the next topic I would like to talk with you about. So modeling, so we were talking about coupling, boundaries, how to find what are the good boundaries, and I'd like maybe to start with a tweet that was published some time ago, and this was about it was saying that microservices are hard, in fact. So building reliable microservices is a lot harder, and testing and following that tweet, we have someone from, I think, Uber, that they are moving back to microservices. So that's like a new term that everyone was talking about, but does it make sense to talk about microservices, microservices? I think a lot of confusion is because micro seems to people little, or has a relation or connection to size of things. What do you think?
People probably took too seriously the micro part of the term, and really tried to split very small part from just a functional point of view, but not from a business point of view and business value. So this is probably why you end there, but actually it's not. You get more complexity at the beginning, but I think merging service after the fact may be sometimes easier than splitting them. So maybe it's not that kind of big problem, except if you had a lot of pain with your many small services. Yes.
Yeah, and we were talking about boundaries, and how do you think, what are good boundaries for services? Vladik talked a bit about and Vaughn as well, about domain-driven design and
yes,
and language, and yeah.
Usually bounded contexts and failure independence and change forces, I would say, are the main drivers for me to find the boundary.
Yeah. I'll share another one. And this one is from Jimmy. So maybe you can comment on your own tweet, Jimmy. I found it.
I already said what I needed to say, I guess.
Yeah. 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 And what can you say about the operational needs? What in the practice, how we can translate that?
I mean, a good example is not having the operational practices. So when one service goes down, then it doesn't bring everything else down. So it's kind of easy to say a pattern name like bulkheading and other ones. Say we'll just implement that pattern, but sometimes the business implications of doing so aren't so clear. If you've built that distributed ball of mud, say, well, if this service fails, we'll just ignore the failure and keep moving. But what if that data that was being returned by the service is needed by the very next call? How does that next call supposed to succeed? So you look at those the things that Jérémie pointed out, the change forces. The other thing I look for is I know when my boundaries are right, when the business is like, of course that should be the boundary. It's kind of the refactoring breakthrough in Evan's book. You've hit the right spot when everyone is in violent agreement and thinks you should have known that weeks ago that was the right boundary, or someone ever just comes out and says that's what the boundary should be. But it's one of those once you hit the right boundary and everyone agrees, not just from the technical perspective but from the business perspective, that's a very good indication that you've hit that right boundary.
Yeah, and how this aligns with business capabilities, because I have a feeling that not everyone gets what's really the business capability is, and there is for the exploration of the language from the domain-driven design is not aligned very well of where the business capabilities are.
I tend to think of business capabilities, boundaries, analogous to bounded contexts, because they both have the same letters, so it makes it easy for me. So that's at least how I have in my head, is that if I align bounded context with business capabilities, at least it's a very good start.
Okay. I check if there is another question.
If I might just add one thing here, and I don't know, maybe this is obvious to everyone, but I constantly run into code at clients where a transaction is committed in some service locally, and as an outcome to that same service makes a REST request over to another service, and everybody just starts laughing right on the panel because we know. And Jimmy, you've no doubt seen this, and it's just and so their response to this is not to change the way they implement the code, but to hire a team of people that the next day, after all the mayhem that's occurred because of the failed, requests to other services, to harmonize, to essentially create an eventual consistency. They hire teams to patch the database, to write these really super complex queries every day to patch the database, instead of just saying, well, why don't we handle this synchronization a little bit differently? So don't do that, right? I mean, don't do the former. Change the way you do that.
Anyone has to add something on top of that? No? It's okay. Yeah. So then the next topic I would say would be running microservices on production. I think we've already spoke about deployments and how it impacts the operation and all stuff, but I think there is a big difference when you move from architecture where everything is synchronous to something that may happen asynchronously. You have all those issues that you have to deal with: exceptions, logging, monitoring of those platforms.
Chassaing.
And many maybe teams that start with microservices, they don't take into account all these things at the very beginning. And what's your experience with that?
Yeah. Yes, one of the difficulty when you start with microservices to actually know what's happening in your system, which is not that obvious at first, because you will probably need some tooling. But in the good part is that once you start to be asynchronous and using message brokers or queues or things like that. One of the cool aspects of the thing already is that once the messages are on the way, you can have a look at them, and by looking at the data, you can know if things are good or wrong. And it's not that easy with HTTP systems with the synchronous remote procedure calls styles, where everything is always on the network and not that easily browsable. So, and the fact that once a service is done, the work will be done by the others, start to make the flow a bit clearer and the whole system a bit more reliable, so is valuable. But after that, you get new concerns, which are knowing what happens where things fail on the way. And when there is a problem with one business case, finding the component that got into trouble is maybe difficult when you have hundreds of services. So this is where you need some tooling for searching logs, seeing traces, having timings, and also a lot of one of the very big aspect is to have not only alerts on the infrastructural level, but also a lot of business alerts, so that when a service is not delivering its value, you get notified quickly to be able to find precisely where the problem is.
Yeah, and the alerts are tricky to do as well, because most of the time, if you don't think enough about it and you implement like aggregate exception and alerts, you can, when something is failing, you can like get thousands of alerts for the same thing. So the debugging such a problem and issue sometimes is very complex. Do you have any recommendations, or someone maybe what are you using to deal with those problems?
System.out.println.
Console.log. Sure.
Yeah, that works really well. Yeah, most of the cases, but
having things to be able to search logs and to create metrics on failure. In the system I'm working on, failure are not an option; they will just happen. So we don't try to spot them individually, but more on the volume scale. So having things like Elasticsearch with Logstash, and then being able to create metrics on failures and to see the trends helps a lot. But in some other cases where most of the failures came from bugs in the code of the developers, there are some other tools than this one to manage. So it depends on the structure of your problems.
Yeah, so when you move to the microservices world, there definitely are different tools and skills necessary than in a monolithic world. And so, for example, to ensure the health of your system, and in terms of like the observability with the three pillars of aggregated logs, distributed tracing, and metrics gathering, there are tools available that you can use. For example, for example, Greylog for aggregated logs, or for Zipkin for distributed tracing, or Prometheus and Grafana for metrics gathering, and also the dashboards by Grafana itself. Or when you move for cloud-provided services, they also provide their own tools that helps you to debug and locate exceptions and error codes, like CloudWatch for AWS, for example, and so on. So so with the microservices, the new world of new tools comes into place. And what I have encountered is this is very important when you start your journey to microservices, that you have these tools ready from the very beginning, because when you try to search for problems when you deploy your services on production and you don't have these tools at hand in place, then you could waste a lot of time finding the bugs, and it then goes into the other opposite direction. Instead of like increasing or improving your software delivery performance, you are wasting a lot of time finding the bugs themselves if you don't have these tools ready, and also the skill set ready. So I highly encourage to have these tools in place from the very beginning.
I had a different experience. I think by starting early the microservices, this tool did not exist this way. So we had to first create some, and then move to existing software that is readily available. But the thing is that knowing that these tools exist is very important today, because they help a lot. But when you start with a few services, because after having microservices, you will probably have tens or 20 services, and the story at that level is not that bad with just logs. If the boundaries are correctly done and the messaging patterns are correct from the business, you will get a lot of insight with the errors and fine. But after this size, yes, of course, you will have to put these tools or this kind of tools into play to be able to manage the thing. Yes. Yes.
Yeah, it definitely depends on the number of services that you are putting on production. But for example, if you have I don't know, you put your service into a container orchestration platform, and it continuously restarts because there's an error, and you can't really access the logs from that one that easily.
It's true that serverless and serverless or containers give less access to the platform. So having the tooling first is more necessary in this case. You're right.
I'm just showing the tweet from someone saying having 1,500 microservices. I know how the company is big, but this is a bit scary. The number of connection, and definitely the tooling should be good enough to find an issue in those kind of systems.
Yeah.
Have you ever seen such?
I saw that tweet, and what was amazing about it is that they were happy.
Maybe they were happy because it was working for them, or
you can show that tweet.
How do they know that? How do they know it's working?
I don't know.
I have a hard time seeing why you could have a unified system like that with 1,500 services that you will keep as a single platform. I mean, if there are some very big problems, but you will split them as several platforms and not use the same tooling for everything, and then you will integrate parts using other system. And I'm really a big proponent of the mesh to have a lot of independent in a large architecture, having a lot of different tools for different teams, for different products and all that, and let each team decide on its own infrastructure and then integrate that. But because this way, each team can tailor the infrastructure to their needs, which are obviously different, and then use integration between those parts. But having this way of saying we have a single network infrastructure for that many services shows that it's too uniform. The day where their network layering or infrastructure decision gets obsolete, for instance, they will have to change the whole platform as a whole. If you have many small systems, each team can take time to move. And since you can already integrate 10 different technology, integrating a new one will be no problem. If you have a single big technology to run all your services, when it becomes a problem for your company, you get a problem for the whole of your system. So be prepared for change. So yeah, I think use many languages, many different infrastructure services split between products or teams to be ready for change. In this case, I think it makes no sense.
Okay. Yeah, the question is also as well, there's a difference between building microservices and building reliable microservices. And how do we build reliable microservices? I've seen many people are using unreliable protocols between different microservices. So it's more painful to make them reliable. What's your thoughts about that? For example, building microservices over HTTP, is that a good idea or?
Depends if it's to serve a request, yes, but most of the things that happen in my system is not request, but can be made asynchronous. So building this kind of thing synchronously would be a mistake.
Yeah. So Jimmy was saying it depends a bit. Yeah.
Yeah. I mean, there's always going to be trade-offs between any communication style, but I've tended to found that the more cohesive my services, then the less likely they have to rely on other ones to be up and running, which means the more reliable they can be made. And if I can make them highly cohesive and lower coupled, then they're going to be up more easily. And if I find I have very fragile uptime, then it probably means I've got something wrong with my boundaries.
Yeah, often. Go ahead, Vaughn. Yes.
Oh well, you can create an entire system that is, 100% REST-based and reliable. It may not have as high, throughput as maybe using, like a very high-end messaging mechanism. But for example, you can use REST endpoints to serve your events, right? I explain that in my red book, that this is not a new technique. You can also now use webhooks and other techniques to keep it sort of low fidelity technology. Everybody understands REST, and so and HTTP, so you can use that, but it may have limits in terms of scalability and performance. I won't say scalability, but I mean you will have to go to greater scale to get the kind of throughput you might get naturally through some sort of a message bus or like Aaron messaging, for example.
Yeah, but doesn't make it more difficult to, handle exceptions and different kind of problems that you might have, because obviously you have to protect yourself, and or everything has to be running at the same time.
You would need, for example, threads on the consumer side that are just interested in consuming and won't take the rest of the service down because the other service becomes unavailable for some time, or you simply, replicate the data that is going to be read enough that you can put a node in front of any of those. And if you can't get the, whatever, you're using a router or you route on your own intelligently, and you say, okay, that endpoint isn't running right now, I'll go to this other one and get it. So
yeah, I would say also like concerning the service interaction types between the services could be also combined, so that you have on the one side like the synchronous REST endpoint that you can use, which is providing a really simple integration type. It just directly calls the other service, which is pretty easy to implement. It does not require an additional component, for example, a message broker in the asynchronous service interaction type. And it also allows you to control the request flow when there is synchronous processing given. And so it's pretty simple, and but it also introduces temporal coupling, as you already mentioned before. Like when one service is down, what happens then with the calling service? And this requires higher complexities in terms of designing for failure, in terms of like timeout handling has to be introduced, and retries. And with retries, for example, we have to make sure that to recover from operations that have failed. So with retries, we have to make sure that the operation that we are calling a multiple times is idempotent, so that this repeated call leads to the same outcome. And another thing is that also helps you to design for failure is, for example, introducing circuit breaker, which protects your entire system from cascading failure, that they are shutting down the connection as soon as after a specific threshold, when a threshold of errors that have occurred, and they come back then when the service is alive again. So it's a simple integration type, but it requires more consideration in putting into designing for failure, which is not with the asynchronous communication interaction type between the services. But there you go, you have to take care. It also comes, there's no silver bullet, right? So when you have asynchronous communication, for example, event-driven service interaction with a message broker, it comes with a separate component that you have to integrate. And you also have to consider that the separate component has to be maintained as well and configured and something like that. It has to be available as well and scalable as well. So it does not come for free, and it's always kind of like measuring what kind of benefits and drawbacks I have.
Yeah, I'll bring one question from audience related to that. Is there a good rule of thumb for how many service-to-service HTTP and gRPC invocation are acceptable? It's like depends on your problem domain, but so no. The answer is there is hard to say. It depends.
42.
Yeah, I'm not sure I understand the question. It depends on your limits are your network and each service side's ability to answer the requests or whatever the demand, right? So that's sort of the limit, I would say.
Okay, I think there is a few minutes left. The time is running very quickly, and I'd like we just bring up some myth about microservices, and we try to answer if this is really a myth or not. So let's start with the first one. I cannot see. What do you think? Microservice monoliths can be easily converted to microservices just by splitting the code and putting it in different deployable units, for example. I think we've...
Vaughn, this one is for you.
It's for me? Oh, I cannot answer that. Go ahead, Jérémie. I think you have an idea of that.
Okay. I think we already mentioned the difference between a monolith and a well-structured monolith and a big ball of monolith. So with a well-structured monolith, the code is ready to run in part of the monolith or not, and it will be probably easier to split. So in this case, it's okay. But yes, when you have a lot of interdependencies between components, moving to microservices will need a large refactoring to get something more structured beforehand, and then you can put in place the integration to actually split the code and go to microservices. So no, it will not happen like that. It will depend on if your monolith has been designed in a way for being split.
Yeah, so the first step would be to go to modular monolith and then eventually to microservices.
Yeah.
Although I did see a JetBrains plugin where you just highlight code and you say right-click, extract microservice, and that's it.
They could do that.
Yeah. They'll be in like Amazon revenue territory with that.
Yeah, another one would be the easy one because we've already discussed it. Teams organization is unimportant. So yeah, obviously we've already said it was really important. And I wanted just to mention one thing that I saw also is that moving people from one team to another can hurt a lot as well. It's not that teams are aligned, for example, to deliver microservices, but moving people around, it's not always a good thing as well, especially if team members are working since a long time and there's some tacit knowledge between them on how they work. So there are many aspects to that. Do you have any experience with that?
Okay.
Talk.
So I would like to bring in, is it me now? I would like to bring in regarding team organization, because it's very important, as we have already identified. I would like to bring in the team topologies book about like how to structure your teams for fast flow of change, in terms of like that you have, for example, the stream-aligned teams that are aligned to the business stream or your business domain specifically, and that you have 4 different types of teams, like the stream-aligned team that are aligned to the business stream, and then you have the enabling team that is then helping stream-aligned team to get their missing skills and capabilities. And then also you have the platform team that provides platform as a service capabilities to the stream-aligned team, so that they are full autonomous, like not only building the services but also delivering them to production. And the complicated subsystem teams that are composed of experts, specialists in a specific complex functionality, for example, video processing or something like that. And so you have these 4 different types of teams, and they have different interaction types. So for example, you're sometimes collaborating a lot with the platform team for a specific period of time, and then the platform team provides their services, their products to the stream-aligned team as a service interaction types, that they provide their services, their platform as a service, for example, or that you are working as a streamlined team with the enabling team, for example, to bring your skills up for how to handling, how to implement asynchronous messaging with a Kafka broker, Apache Kafka message broker, for example, or then also the complicated subsystem teams helps you to bring in some specific, specialized functionality that you helps you to deliver your functionality faster or your features faster. So, and there are then it's dynamic structure. So the teams themselves they stay the same. So they are not switching between the teams, usually not. But it could form different along the time. They could communicate and collaborate differently. And sometimes you're working closer with this team, and the other time you're working closer with that team. So this was really what I really liked a lot about this. Like, you have your types of teams that are focusing on your fast flow, but the interaction types between your teams can change over the time.
Yeah. One thing I wanted to say is that about teaming organization is that we talked about Conway's law, and the mistake with Conway's law is to look at the official communication diagram, because usually there is an unofficial communication diagram which is totally different, where people from different teams talks a lot or eat together for lunch every day, and people who are friends outside of work and all that, and you have to take this into account to make it work truly. So look not only at the official diagram, but also understand the real communication between people before moving teams, because you can break efficient communication that already existed and lose something in the way.
Yeah, so sometimes ago, like, people were just copying Spotify model, and it turns out that it doesn't work very well if you are not Spotify.
Yeah,
it didn't work well for them either.
Yeah. So what Susanne said just before, yes, the Spotify model is quite interesting, but the main idea is mostly that you can have roles that span over teams. So you have products, you have roles. It's important to have a balance between roles like management, technical decision, business decision around all products, and collocating them due to Conway's law tends to be more efficient. But then it does not always mean that you have one people per team that does that. You can have people who spans teams and all that, but the communication has to exist anyway.
Yeah. Yeah, there is few left, don't worry, we'll be in time. Another one is just time to market is faster with microservices. I think it depends, like always. So,
Yeah.
But yeah, so
time to market is better with high cohesion, loose coupling, right?
Mm.
So.
Anyway, okay.
Time to job market is faster?
Definitely.
Yeah. So another one, microservices is just SOA well done. So what's SOA? I think no.
Maybe the tweet you just showed before is the indication that it's a myth.
Yeah, because like before microservices were hyped, everything was a fault of SOA. So that's I think now it's a fault of microservices, and maybe next few years we'll say that we'll come back to monolith again, and we'll have to do the same route over and over again. Yeah, so another one, micro, because it's small. So we've already discussed size is unimportant, in fact, but most of the people are confused because of the micro with some kind of connection with the size, obviously, no?
Yeah.
So, okay. That's the another one. We want loosely coupled services, so we will go microservices. But going microservices, is it the government have the loosely coupled services? We've discussed it, but you agree that it's not so obvious. Okay. Microservices are more scalable than monoliths.
This one is tricky.
What do you think?
I guess so. You can also scale a monolith, right? So it's not a problem to scale monoliths. But I guess microservices are, because you have the ability to extract services with different resource consumptions, and so that means that you can scale them independently. And I guess microservices provide better scalability in terms of the cost effectiveness. So they are better scalable cost effectively, I would say.
Okay, so let's take another one. Microservices help maintainability and uptime.
I don't know, some of the systems that had the least uptime I've seen were microservices. So
the thing is that you can more easily have partial failure with a system that still works. I think it's rather well doable. So yeah, you can do this, but for this it has to be designed in this goal. So yeah. If you have a lot of services calling each other synchronously, and any one failing is making everything fail, no, it will not be more reliable, of course.
Yeah. And the last one, it's microservices and containers are a perfect match.
Everything is better with containers, not only microservices.
Well, I mean, I think it's true from the standpoint of if you can have something else monitoring your services and make sure that if one crashes, one replaces it somewhere, that's a pretty good benefit. I mean, you don't have to write that code, but just thinking because you put some artifacts into containers that it makes you successful, no.
I would add to this one that also, for example, a backend API implemented as microservices also match perfectly with serverless technology as well. So it doesn't have to be in containers. It can also be serverless technologies being in place.
Yeah, I think we've pretty discussed all topics around microservices. Of course, given the allotted time, we cannot go into details. But yeah, is there anything you would say for at the end, give advice to people that want to implement microservices, or what would you say first? Vaughn, go ahead.
Well, don't change shiny objects. And just to be clear, I don't think that microservices are currently the shiniest object, right? In other words, they've been around. There's been experience, large, highly scaled, businesses like Uber are saying ouch, and so be careful what you wish for. But just use common sense. Does this need to be smaller, independent, autonomous, and even if it is, it could still work in a monolith because you can accomplish most of those things even in a monolith. And just remember that unless you're FANG or some, as in those number of companies or somewhere in that realm, you're probably taking a huge risk to try to accomplish those goals because you probably don't need it.
I would recommend to use microservices if they solve the real problem you have. And in the way you will trade some of the problem you had for other problems that you didn't have before, and be sure that you win on the way.
Yeah.
I would say if you ended up with microservices, then always make sure you're examining and evaluating the boundaries of your services. And look at those endpoints that those services are exposing. And consider, for example, what would happen if you were to merge two services. Would that merge eliminate some endpoints? If the answer is yes, then probably the composition you already have adds some system-wide complexity. And maybe that's a strong heuristic for re-examining your service boundaries.
And also adding to this one is that, for example, according to Conway's law, but also Michael Nygaard, the author of Release It, has mentioned that team assignments are your first draft of your architecture. And so that means, and also coming back to the inverse Conway's law maneuver, means that you have to rethink about like your team assignments, your team structure first, and assign this first or restructure this first before you go into restructuring your software, because it has a huge impact, or it has a direct impact on your software architecture itself. So that you first restructure your teams first before you go restructuring your architecture style into microservices.
Okay.
So the one thing I see overlooked a lot for teams moving towards this is the people aspect, the change management aspect of it. And unless you can effectively move the organization into the place where microservices are going to be successful, then it's going to have a much harder time succeeding. So it's not just the technology aspect of it, it's going to be many other aspects as well. So invest in your communication techniques and your persuasion capabilities, because that will go just as far as any of your technical capabilities.
Yeah, that's really great. I would just add to that for most of the time we don't look enough where the value stream is and what the stakeholders to the software architecture are, because most of the time the software architecture is like owned by the technical engineering teams, but in fact it's impacting the whole company. So I would say that this is the important part to distinguish what are the stakeholders, like customers, users, business people, domain expert, and to really estimate what kind of contribution they have and how they impact the whole architecture. And that's the point I would say that's very important. And unless this is not clear enough, going to microservices will, for me, cause more pain than benefits, and it will impact more the people that are paying teams, engineering teams, for developing different kind of, software applications, and on top of that, I think we are almost we are done discussing microservices, even if there is a lot of stuff ongoing, and there is a question if for the Friday evening I can play something on the guitar, but I think it won't happen this time. So thank you very much for this discussion, Jérémie, Vaughn, Vladik, Jimmy, Susanne. It was a real pleasure to have you on the call. So I'll end up just saying that if you'd like to subscribe to different topics and channels, you have the Twitch channel for the Office of Strategic Software and YouTube for DDDFR. There will be new events online coming. Yes, the situation is that the physical events are quite limited, so most of the people are meeting online. Thank you very much, and I hope you enjoyed that.
Yeah, thank you.
Thank you for inviting.
Thank you.
Thank you for inviting me. It's nice to get together with everybody.